So in this video, we will talk about auto failover and ECMP with Fortinet. So Fortinet is a good small, medium enterprise firewall, and it has good feature set, but especially this one, I wanted to put this out there because this is not configurable through a GUI. So if you're looking for this feature on a Fortinet GUI, you would not find it. You have to go through the CLI to enable this, and that's the interesting part. Now, this is the setup that I have here. You have a firewall that could be connected to a switch or two switches for redundancy, and the ISP1 is coming in and an ISP2 is coming into the same firewall. And this is your internet address that you're trying to reach, 200.111. It's configured as a dummy interface on VIOS 2 and VIOS 3. And these are your segment addresses here. The firewall is configured with port 1 as management. This is my laptop right here. 192.168.71.132. If you configure the DHCP on the port 1 and allow HTTPS, it will let you, HTTP and HTTPS will let you log in. Again, this is the virtual machine that I'm using, evaluation virtual machine that you can get from Fortinet. And it lasts for 30 or 60 days. Once you put it up in a VMware player, you can configure all this stuff. In my case, port 1 is management, port 2 and 3 connected to the ISPs, and port 4 is connected to the VIOS 1. And this is, let's just say, the inside LAN users that are trying to connect to the ISP address or internet 200.111. So I'm running a ping on this guy. To reach this address, and obviously the policy is not configured, I can ping the addresses, but I've pre-configured that stuff. So I can ping my default gateway here. My default gateway is 132 on 10 network. So I should be able to ping 132, and my routing information for VIOS 1 is a default gateway 10.0.0.132 this address. So for any address, I'm just going to my firewall. Straightforward for VIOS 1. VIOS 2 is also straightforward. I have no default routes. It's just a segment, and it's got two interfaces, one on the 20 segment, and the dummy interface is on, configured with 200.111. Similar is the setup for VIOS 3 as well. 30 segment right here, and it's got a dummy interface with 200.111. So my LAN router is going to be reaching 200.111. We're going to failover and see how that works. So right now I'm not able to ping because I don't have a policy. So let's configure the policy on the Fortigate firewall. It's a virtual machine. You can download it from Fortinet website. Port 1 is configured with DHCP. I can also show you, once you bring up the virtual machine, you would have to do this on the virtual machine. I do have a video on it, but I'll go through it again, but I do have a video on bringing up a virtual machine on Fortinet. Port 1 configured with the management interface, DHCP. This is really a DHCP interface. DHCP, it automatically gets the address, and then you can connect. You have to enable HTTP and ping and FMG access. You would have to do this through the CLI because, and then that's what the video covers. Okay, so port 2 configured with 20, port 3 configured with 30. All the administrative access is enabled for pings. And port 4, the LAN interface is configured with 10. Now let's go configure the policy so that this guy can reach 200. And for that, we go to policy and objects, firewall policy. Now the way this is going to work is when you create a policy, let's just say LAN to internet, your incoming interface is going to be a single interface, right? So let's just say in our case it's port 4. And you see it won't let you add another port. So if you need more ports, you're going to have to create zones. So outgoing interface, we have 2 in this case, 3 and 4, right? If we look at our map, we have port 2 and 3 that we need to configure as outgoing. But it would only let you put in 1. So that's not going to work. What we're going to have to do is we're going to have to create a zone, ISP zone, that would include port 2 and port 3 in ISP zone. So this port 2 and port 3 is going to be in ISP zone. Okay. Let's go to new policy, cancel. The way we create zones is we have to go to the interfaces and then do a create new zone. See that? So now the zone will include, say it will be called ISP zone. And we're going to include port 3 and port 4. Make sure it's port 3 and port 4. No, it's not. It's port 2 and port 3. Port 4 goes away. Port 4 comes in. Port 2 and 3 comes in. ISP zone, port 2 and 3 is configured. Port 2 and 3. And port 4 is your LAN. Now you go configure the policy. And your policy is going to be straightforward in my case. I'm going to create a new policy and call it LAN to internet. And my incoming is port 4. Again, if you have multiple ports, you're going to have to create a zone. Outgoing is an ISP zone. So now you put the zone which has the ports. Source, just say any. Destination, just say any. And schedule all this service, we just say all. And we'll use NAT so that we don't have to create default routes here. And that's it. You press OK and this guy should start pinging. And it's not pinging because you don't have static routes. So the firewall doesn't know. The firewall needs to know how to reach 200. It can reach 20 and 30, but doesn't know how to reach 200. So we're going to create 2 default routes. Quad 0. Gateway address is going to be 20.00.2, 30.00.3. Okay. Quad 0 interface 2 Interface 2 is 20, interface 3 is 30. Interface 2, quad 0 gateway is 20.0.0.2. Make sure the administrative distance and the parity is the same for both the default routes. Okay. And now we're going to create another one. Port 3. Gateway is 30, 003, 10, and parity is the same. So now that we have the default routes, there's another problem with the virtual machine, and I'll show you what that problem is. This should start pinging, right? And it's not. So when you go to the CLI of the firewall, and this is more like a bug, right? So here's my CLI for the firewall. If you look at the static routes in the GUI, it'll show you quad zeros too, right? Now, if I go get router info routing table all, there you go. You see what's going on here? You have a quad 0 going to port 1. Port 1 is my management. And this is a virtual machine thing, right? It's a bug, or you can call it whatever. Advanced feature from Fortigate perspective. But you don't see the two quad zeros, default routes, right? And this is what it's doing. So how do I disable this? Simplest way is to go to the network interfaces, okay? And port 1 is where it's pointing to. And then what you're going to do is edit. You got the DHCP address for your management, but what you got to do is say retrieve default gateway from server. Disable that. Okay. And it's not going to get rid of it. So you're going to have to reboot it. So you're going to have to reboot it so that it gets rid of this, because if you go into the edit, it's not going to let you delete that static route. So this is again a virtual machine thing, so a lab setup. So I'm just going through this so that when you configure this, you'll have to go through all this stuff. So let's reboot it. Reboot. Okay. Once it comes back up, we'll check the default routes again. So this guy's rebooting. And once it comes up, this guy should start pinging automatically. It's making progress. There you go. Soon it comes up, it start pinging, right? So let's go check. Get router info routing table all. Now you see the two default routes that you configured, right? Okay, so that's a glitch in the virtual machine, I would say, but be aware of it if you're testing something like this on a virtual environment. So let's minimize this guy. We got the pinging going. We don't know which route it's taking, so what we're going to do, I like this feature in VMware. What we're going to do is increase the latency and see. So V2 will just increase the latency on this guy. And we're going to say on this network, this guy's latency is going to be 300. So it is going this route. So, right, it's going this route and it's not taking this route. Now, we got this basic connectivity up and running. Now, you got the two routes, default routes, but now let's fail it and you'll see it's not going to work. By default, it should work, right? In a router, it's going to just switch over. So if I fail this by saying do not connect, disconnect, you'll see that it's not going to fail over. It's going to get stuck, right? It will fail over when it reboots, but the circuit failed here. Our intention here is that the circuit, the firewall automatically fail over to the next circuit, auto failover, right? And it's not doing that. So we're going to have to configure all this good stuff to make it happen, which is straightforward. So let's just going to do enable this guy to bring it back up. Connected. And it's going to come back up. All right, now we'll go configure this good stuff. CLI only, GUI doesn't have it. So we bring up our firewall. And we put this good stuff here. We do config. We do config. So link monitor. All right, so that's what we got to do. Config system link monitor. You got to pay attention here. So config system link monitor. Again, this is not a GUI feature. You got to go through the CLI. Config system link monitor. You're gonna have to name it. So you can just say monitor port 2. Enter. Okay, what? Link monitor. Oh, okay. Config. This is Fortinet, right? So config system link monitor. Enter. Edit. Now you put in the name monitor, or I'm using link monitor, so I'll use the same thing here. Edit link monitor. LNKMTR -P, P2 port 2. So you can use whatever name you want. I just use this one. New entry for link monitor added. Okay, now I'm going to say, I'm just going to follow this guy now. Set this, set this, set this. I'm not going to configure this guy. This is a default. So go back. I'm going to say set source interface port tab port 2. Set server 200. I'm trying to monitor 200 if I can reach 200 or not. Set gateway. What's my gateway to reach it? 20002 for port 2. Next. So we're done with this part. Now we're going to the monitor the second link. Next, edit link MTR port 3. Added. Set source interface port space port tab port 3. Set server, same thing. In real life, you'll be doing 8888 Google DNS, right, or any other DNS that's public for monitoring this reachability. And then set gateway for port 3 is 30.003, and then I'm going to say end. All right, so this should take care of the failover part. Haven't configured the ECMP. ECMP is load balancer, right? So we'll take care of that later. Let's test our failover now. So this guy's going through the high latency thing just for our distinguishing where it's going, and we're going to fail it over. See what happens. disconnect, and let's see if this guy fails over. There you go. It fails over to this guy. So let's put the latency just to make sure that we are reaching this guy. Latency is going to be 50. Okay. So yeah, then we're reaching here. Now this circuit comes back up. And it's gonna fail back or stick. It's probably gonna stick to the secondary. Let's see how it behaves. So yeah, it's sticking to the failover circuit until you prioritize the routing to say which one is preferred. But anyway, so we have successfully configured the failover, right? We have successfully configured the failover between two ISPs, and this LAN router was trying to reach them, and without this configuration, it did not. So we had to put this configuration in. It's not a GUI feature. You have to go and put in all this stuff. It's non-disruptive, as you can see. You can do it in production. It's not going to disrupt your existing traffic, and that's going to take care of it. But the only catch is that if you have only used ports, then you'll have to create a zone to put in the 2 ports, ISP ports, and then your outgoing will be the zone, ISP zone that you would select in your policy. So that may be a little disruption if you don't have a policy like that. You'll have a policy, you create a policy, parallel policy, and then do all this good stuff. But I think it'll still be a little disruptive. But it's the most straightforward mechanism, in my opinion, for Fortigate to fail over between the 2 circuits. Now, if you go to the Fortigate website and then you pop up the CLI, and you say execute ping to 200.111, and it's taking the second one, so it's automatically load balancing between the two routes. This one he's forwarding it off the secondary one or second ISP, and this one he's throwing out the primary. So because the default routes get router info routing table all like that, yeah. So the default routes are there, port 2 and 3, and you don't see the you see the admin distance, but you don't see the priority. That's another problem. So to see the priority, I'm sure there's a CLI way, but you will have to go to the network and then static routes to ensure that your priorities are the same for load balancing, priority 0. Now you can go ahead and also configure the ECMP according to their website, that you put the set ECMP mode to source destination IP based or whatever other options there are, and we can demonstrate that but there's no way for me to prove that the ECMP is working at this point in time. So we do config system setting and then say show, and it's got nothing in it. So you're gonna do set v4 ECMP mode, and you do question mark, and it'll show you source IP based, weight based, usage based, source destination IP based. So these are the options. And then you'll have to, let's just say you say source destination based, and then you say set ECMP paths maximum. You have to provide that. So if you have 2, you just set it to 10 or whatever, but by default I think it's 1. So you're gonna have to do this to ensure that it's load balancing. All right, so I hope that shows how you can do the auto failover and ECMP through CLI, and I demonstrated that just by configuring the 2 default routes, it's not going to fail over dynamically. You're going to have to configure this part, and then it's going to fail over. And you can, like I said, the VMware has a good feature to enable latency to, for you to check if it's failing over. So the question in my head was after this was, okay, why do you need SD-WAN then? So SD-WAN obviously is a similar but not same feature, right? In this case, auto failover is just not considering anything from a latency and packet loss perspective. It's just monitoring something on the internet, and then when it's not able to reach it through one path, it will fail over to the second path. So it's not considering latency, or it's not considering packet loss either, right? For SD-WAN, you can configure latency, packet loss, and other stuff. On top of that, you can also have different application signatures or profiles for each. So application 1 is more sensitive to latency, so it'll have a different policy for that. Application 2 is more sensitive to packet loss, so you'll have a different profile for that. So SD-WAN is much more advanced, and it's not simply a failover mechanism. It's much more advanced based on application profiles or signatures, destinations. It's much more enhanced. But just to do a simple ISP failover, if you don't have any application requirements, you'll just configure auto failover and you should be done. I hope this helps.